Well, I think time now is for some real business, my dear students, because we are going to start calculations. Before starting, I'd like just to say that you were supposed to study how to calculate all the correlation coefficients, those I explained in earlier video, all of them. But because I said that I'm not going to stick to what you are supposed to study and reduce the quantity of information I'm going to teach you for this semester, how lucky you are. So I'm going to stick with only Pearson correlation, the Pearson correlation, or RP, because it's the most used one, the easiest one, and the most famous one, and probably is going to be the one you are going to be using next year, inshallah, in your dissertations. So please focus with me. I'm going to show you how to calculate the Pearson correlation coefficient using two techniques, the simple formula and using the standard deviation. So for the first technique, all you need are the two variables. So here I'm having my two variables, which are statistics exam scores, which I'm symbolizing with X, and the research skills scores. So I'm trying to check if there is a correlation between my student statistics exam scores and research skills exam scores. Is there a correlation or not? This depends on the value of the correlation coefficient. So what is the next step? What do I need to do? So you need to square X, square Y, the values, each value, and then multiply X by Y. Let's see. So I need to square the values of X. So the square of 2 is 4, square of 3 is 9, the square of 5 is 25, and the square of 7 is 49, the square of 8 is 64. I need to square Y now. The square of 5 is 25, square of 7 is 49, square 6 is 36, square 10 is 100, and the square of 2 is 144. 12, sorry, square of 12. Now let's multiply X by Y. So X multiplied by 5 by Y, or 2 times 5, 10. 3 times 7, 37, 35. 5 times 6, 30. 7 times 7, 70. And 8 times 12 is 96. I think this is clear. Now, what is the next step? You need to find the sum of each of them. The sum of X, the sum of Y, sum of X squared, sum of Y squared, and the sum of X multiplied by Y. So the first sum is 25. So 2 plus 3 plus 5 plus 7 plus 8, 25. 5 plus 7 plus 6 plus 10 plus 12, 40. 4 plus 9 plus 25 and so on, 151. 25 plus 49 plus 63 and so on, we have 354. And the sum of this line is 10 plus 35 plus 30 plus 70 plus 96. We'll have 2,227. Here is the simple formula. Look carefully. So RP equals N times the sum of X and Y. So N times the sum of X and Y. So where is the sum of X and Y? Here it is. Where is N? Here it is. Then minus what? Minus the sum of X times the sum of Y. All you need to do is follow the rule, that's all. And all divided by the square root of N times the sum of X squared minus the sum of X squared times again, or multiplied by N times the sum of Y squared minus the sum of Y squared. You have to make the difference between the sum of X squared and the sum of X squared. In this time, you are just finding the sum of X squared. Here is it, X squared, this is the sum. But in the other case, no, it's the sum of X squared, so the square of 25. Here is, let's put the numbers. let's put numbers here. So where is n? N is 5. So n is 5. What is the sum of x multiplied by y? X multiplied by y. Here is it. 227. Minus sum of x 25, and the sum of y, which is 40. And then let's go down. N times, or n multiplied by the sum of x squared. So here is n, 5, and the sum of x squared, 151, minus what? The sum of x squared, so the square of 25. Again, we will do the same with y. So for n, 5 times the sum of y squared. So here is the y squared, the sum, minus what? The y, the sum of y all squared. You will end up by find this, and this is the value after doing the calculations, of course. Here is the value of our P, or Pearson correlation. It's 0.9, which again means that we have a correlation that is very strong correlation, if you still remember. Now let's check how to calculate the Pearson correlation coefficient using the second technique, which is the technique of the standard deviation. I hope that you understood the simple formula, because it's very easy. Now it's time for a bit complicated. I think it's complicated, but I don't know. You may find it easier. So what you need to do to use this technique. So in the statistical table, you need to prepare some calculations here. So the first step you need to do is find the x bar and y bar. Find the means of the two variables. If you can notice, those are the two variables, the same two variables, x and y. Find x bar and y bar. I calculated it, so I have 5 for x bar and y bar equals 8. Nice. Then calculate the deviations of each of the scores from the mean. Okay, what are you doing here? You are measuring the deviations. We have seen these when we were studying the lecture of variance and standard deviation, if you still remember. So the deviations of x from x bar, so you will take or subtract each of these from the mean. Okay, so 2 minus 5 equals minus 3, 3 minus 5 equals minus 2, and 5 minus 5 equals 0. 7 minus 5 equals 2, and of course 8 minus 5 equals 3. It's easy. Now we'll do the same with y. So 5 minus 8 this time, y bar, equals minus 3, and 7 minus 8 minus 1, 6 minus 8, you will have minus 2, 5 minus 7, no, sorry, 10 minus 8, you will have 2, and 12 minus 8, you will have 4. I'm going to give a symbol of dx for the first deviations of x and dy for the deviations of y. So this is dx. D means or refers to deviation. So dx and dy. So the resulting values, we are going to multiply them. So multiply dx by dy. Dx by dy. Okay, so minus 3 multiplied by minus 3 will have 9. So the minus with the minus will have a plus. Minus 2 multiplied by minus 1, you will have 2. Minus again with minus will have plus. 0 by 2, 0 multiplied by 2, we have a 0. 2 multiplied by 2, you have 5. And 3 times 4, you will have 12. I think it's easy. Now, again, we are still working with dx and dy. Now, square dx and dy. So the square of 3 minus 3 is 9. The square of minus 2 is 4. You may be wondering, for those who cannot understand, where is the minus? The minus goes because it's square. 0, the square of 0 is 0, the square of 2 is 4, and the square of 3 is 9. The same here. The square of 9 is 9, 3 is 9. Square of minus 1 is 1. The square of 2 is the minus 2 is 4, the square of 2 is 4, and the square of 4 is 16. The next step, of course, you are supposed to find the sum of all the lines or all the scores you have. So the sum of x, just like in here, 25, and the sum of y is 40. The sum of the deviations, be careful, is always 0. Sorry, it's always 0. Okay, so to know if you are really doing a good job, you have to find that the sum of the deviations is 0. Now, the sum of dx multiplied by dy and dx squared and dy squared. So here are the sums. Now let's apply the rule. So the formula says that Rp equals the sum of dx multiplied by dy. So the sum of this, which is 27, all divided by n minus 1 times standard deviation of x and standard deviation of y. What does this mean? It means that I need to calculate the standard deviation of x and y. And of course, you know how to calculate the standard deviation. Here it is. Standard deviation of x equals the sum of dx squared. So the sum of x minus x bar squared, which is this one, divided by n minus 1. This is a rule. We have seen it in class. The standard deviation of y equals the square root of the sum of dy squared divided by n minus 1. Okay, let's do it. So sum of dx is 26 divided by 5 minus 1. Remember, n is 5, and you will have 2.54. Now, standard deviation of y is 34 divided by 4 and minus 1, and the square root, you will find 2.91. Take these two, put them in here, and we'll have this. So we said that it's the sum of dx times dy. So here is the sum of dx times dy. We put it in here, then divided by 4, which is n minus 1, 4, 5 minus 1, multiplied by standard deviation again, here it is, of x and the standard deviation of y, and you will have the Rp, which equals again 0.9. Here is the same result. What do you think? Do you think they are easy? Which one is easier than the other one? This is what you are going to tell me when you see the video. So thanks for watching, and see you soon.